Welcome back to my channel Success Engineering Official. So in the last tutorials I explained you how to calculate the ESP with ASHRAE duct fitting database software, but there was incomplete. Actually we did until this branch, until this tag number 4. So we have to continue this and to finish this in this session. So let us start now. So you can see this is your fourth tag number 4th, and this is the straight duct. So next is our elbow. So for we have to calculate for the elbow and straight duct, VCDs, etc. So let us continue with this session. So before I start this session, I would like to request you guys once again, if you are still not subscribed my channel, please do subscribing, and also hit the bell icon so that whenever I upload the video, you will get the notification of that video. If you not on the bell icon, then you will not get the notification. Okay, so also please like and share my video. So let us start now. So tag number 5 is there. This is our Excel sheet, and third is straight duct. That is a straight duct. Then fourth is also a straight duct. So number 4. Number 4 is a straight duct. So let us continue for the straight duct. Okay, and the size is same. And length is, let us check the length here in the AutoCAD. So enter the DLI command. DLI is nothing but the length, linear length. Okay, and 670. So enter here 0.67 meter, and airflow is 1628. Okay, and for this one, let me open this ASHRAE duct fitting database software. So we'll calculate with this software, but for actual practice we are using actually this software. So just to save the time, so here height is 450 and width is 1000, I think 1000. Okay, and length is zero point 0.6 meter, 0.67. Okay, and airflow is 1628. 1628, and click on calculate. So I'm getting 0.1 here. Okay, so let us continue with the fifth, that is 90-degree elbow. Tag number 5th, 90-degree elbow. And size of this elbow, you have to check it here. Actually height will be 18 inch and width will be this much only. Okay, because this much of here will pass. So 500 by 450, I think 18 inch is equal to 450. So length of the elbow is 500 by 450. So 90-degree elbow, and size is 500 by 450. Okay, and length is, you have to check the length here. So enter again DLI command, and length is here 600. So 0.6. Okay, and airflow is now changed because some of amount of airflow is go to this side and some is going to this side. So airflow is 2120 cfm. So 2120 divided by 2.119 is nothing but liter per second. So I am getting here 1000 liter per second. So here 1000 liter per second. Okay, and let me calculate the pressure loss. That is nothing but here elbow. Go to the elbow and meter radius, a smooth radius. Okay, and without vein. So here is your height. Width will be 500 and height will be 450. Okay, and radius is 1.5. Do not change this. Angle is 90-degree and airflow is 1000 liter per second. Just click on calculate. So I am getting here 2 pressure loss, that is nothing but in Pascal. So 2 Pascal I am getting here. Again, tag number 6 is nothing but this VCD. So for the VCD also we can calculate here VCD. Okay, and size of the VCD will be same as the elbow, and length is 100 mm, 0.1, sorry, 0.15, 150 mm actually this VCD size. Okay, and airflow is same, 1000 liter per second. So go to this software and you can calculate here, you can find your damper and butterfly. So butterfly damper, okay, and height will be 450 and width will be 500, okay, and angle is 0 degree, leave it because we have to open full, and airflow is 1000 liter per second. Simply click on calculate. So I am getting here pressure drop is 1 only, 1 pascal. So let us enter here. Okay, and next is 7. So tag number 7 is nothing but your straight duct. So just check the length here. Okay, length is from here to here, so 2.1. Okay, and the size is 24 inch by 18 inch. 24 is nothing but 24 into 25. I am getting here 600 by 450. Okay, so here is a straight duct, 600 width and 450 is height, and length is 2.1 meter. Okay, and 1000 liter per second, because same airflow is passing through this duct. Okay, so 1000 liter per second. So go to this straight duct, enter the height and width. Length is 2.1 meter and airflow is 1000 liter per second. Simply click on calculate. So I am getting here zero point 0.6 pascal. So 0.6 pascal. Okay. Similarly, you have to calculate for other tag that is here reducer. Okay. So for the reducer, the size of the reducer is 600 by 450. Okay. So here reducer 600 by 450, and this side is 18 inch by 16 inch. So 450 by 400. Okay. So 16 is nothing but 400. So here 450 by 400. Okay. And length you have to check from this drawing from here to here, and it is 400. So but the reducer length is minimum 450. So enter here 450. Okay, and airflow is how much is the airflow here? 1405 cfm. So convert into liter per second. So 1405 divided by 2.119. I am getting here 663 liter per second. So 663, once you enter here, it will convert in cfm 1405. Okay. So go to this reducer. Go to so where is reducer here? Let me check reducer, other elbow, then supply exhaust. Go to the supply. Okay, and then you will get it, I think here rectangular. Yes, transition. Okay, so go to this transition, and here is two side parallel. Okay. Enter the height, that is nothing but ho is nothing but this height. Okay, and this is the h1. So enter the height here, that is nothing but this height. Okay, so 16 inch is nothing but 400. Okay, and width is 450. Okay, and then h1 is 450, and then length is 0.45, that is nothing but 450. Okay, and airflow is 663 liter per second. 663, simply click on calculate. So I'm not getting here any value because this software is calculating the difference of 100 mm only. So your reducer size, always you put here 100 mm difference in the height. Okay, so you can see here 450, so you can enter here 500 and then you click on calculate. So here pressure loss is nothing but 0 only. Okay, so here is 0, no pressure loss. Okay, and 9, then 9 is again a straight duct. So straight duct will continue up to here. Okay, up to here. Okay, so let me calculate from here to here, check the length. Okay, it is 3.7, 3.7, and size is 400 by 450. Straight duct 450 by 400. Simply copy this. Okay, and 3.7 is the length, and 663 is nothing but the airflow. And check this, go to this software, ASHRAE duct fitting database software, and you can go to this common and where is straight duct here. So height will be 400 and width will be 450, and length will be 3.7, and airflow is 663 liter per second. Click on calculate. So I'm getting here 1.3 Pascal. So 1.3 Pascal. Okay. And next is 10. 10 is nothing but the straight duct again here. But airflow is only changed. So let me check the length from here to here. 2.4 and 50. What will be the airflow here? 50 CFM will be less. So 665 CFM. Okay. 2.4, and duct size is 12 inch by 12 inch is nothing but the 300. Okay, so a straight duct and here size will be 300, 300, again 300, 300. Okay, and 2.4 is the length, and airflow 665 liter per second CFM. 665 divided by 2.119, that is 314 liter per second. So here 314 liter per second, and here 300, again 300 height, and then 2.4 and 314 liter per second. Click on calculate. So I'm getting here 1.2 Pascal. 1.2 Pascal. Okay, and then again here 11. So your 11 is tag number 11, straight duct only. So actually this naming is little bit differ. So 11 is a straight duct, same this one 11. This is 11 actually. Here is 12. So for the 12, 12 is nothing but your contraction. Okay, so click on the contraction, then VCD. This size will be how much? 300 by 200. This duct size. Okay, okay, so 250, 250 by 300, 200, and this size is 350. So here contraction is nothing but contraction. 350. Okay, 350 by 200, and then here is 250 by 300, 200. Okay, and length is 150, so 0 0.15. Okay, and airflow will be how much is the airflow? Let me check here. 345 CFM. So convert into liter per second. So 345 divided by 2.119. So 163 liter per second. So 163. Okay, and go to this pyramid, okay, contraction, and height will be 250, okay, 250, sorry, 200 and 200, and width will be 350, okay, and here is 200 and width is 250, okay, and length is 150, 150 mm, okay, and airflow is 163. Click on calculate. So here getting 2 Pascal, okay, so 2 Pascal. And next is 13. So 13 is nothing but your damper, okay. So for damper, I have calculated here for the damper BCD, so I am getting here 1. So here simply enter the 1. Air loss is airflow is 1, and pressure drop 14. So 14 is nothing but reducer again. So for the reducer, you can calculate same. So reducer I am assuming 1 here, and 15 is nothing but VAV. So for the VAV I am entering here, so number is 15 and here is VAV, okay. So VAV is 1, and this is the pressure loss for the VAV is given by supplier, so it will be approximate 10 Pascal, okay. I will show you the supplier list as well. So I am assuming the 15 10 Pascal, and whatever the supplier will give you have to enter here for the accessories. Also you can get the pressure loss for the dampers as well from the supplier, okay. So next will be your reducer again, and then a straight duct. So I'm entering here reducer, okay, and I'm entering assuming 1, and 16 is nothing but a straight duct. So for a straight duct here, 300 by 250, 300 by 250, okay, whatever it is size, 250, and length is, just check it from this drawing, okay. So length is nothing but from here to here, okay, 1100, that is nothing but 1.1 meter, okay, and airflow is 163, and go to this straight duct, okay, and interior height, so height will be 250, 200, sorry, and 300 is nothing but width, 1.1 is length, 163 liter per second. Click and calculate. So I am getting here is 0.5 only, 0.5. And the last is nothing but the flexible. So for the flexible here, 10, uh, 17 flexible. So for the flexible, 10 Pascal. Okay, also, and the last one is the diffuser. So for the diffuser, we have to calculate with this software, Vita software. Or supplier is also giving from the supplier catalog, you can found as per the size, or you can ask from the supplier. So let me check the size first. The size of diffuser is 300 by 300. So let me open here Vita software, and how to select with Vita software I will show you here. So ceiling diffuser and supply, okay, and SI unit square, then go for selection. Okay, NC value is 35 maximum, and liter per second is 163. Vmax Vmax is nothing but 450 meter per second maximum velocity, and find the nearest match. So it's already showing here, but we have to change the screen brightness. So go to this personalize high contrast and switch it on. Okay, now you can open this your Vita software. So you can able to see here. So here throw is 5 meter and AK is nothing but the neck pressure loss. Okay, and here is the pressure drop. PT is nothing but the pressure total pressure drop 3.3 3.1, so 3.134 of water gauge. If you calculate change the unit, let me change the unit. So let me select again ceiling diffuser imperial. Now I'm going to select imperial square, then here is Vmax 35. CFM is nothing but 345 CFM, 345 feet, 500 450 feet per minute. Okay, and find the nearest match. So you can see here 0.041 inches of water gauge. Convert into Pascal. So 1 inches of water gauge is 250 Pascal. So here 0.041 into 250. So you can get approximate 10 Pascal. Okay, so simply enter here. Let me change the contrast first because it is not looks good. Okay, so it unable to open. So here is your 18 and this is nothing but the supply ceiling diffuser, and number quantity is 1 and Pascal is 10 Pascal. So let me close this. Okay, then I will change the contrast, then I will explain you the result first. Save, save. Okay, close this software as well. Go to high contrast and switch it off. Okay, and then I will explain you the final result. Okay, so let me open this. Okay, ESP calculation. This is our final result. So you can see here the total ESP is nothing but 50. Losses in duct and fittings is 52.4 Pascal. Losses in duct fitting and accessories total, that including accessories, so this is your accessories, 40 Pascal. So if you add these two, you will get it here 9.2 or 922.4 Pascal. And safety factor is 15%, that will cover your whatever is something is missing, so you will be safe. And total ESP is nothing but 106 Pascal. So I hope you guys learn how to calculate the ESP for this for actual project using ASHRAE duct fitting database software. If there is written duct, so you can calculate similar with the supply here and enter here is this value. And if there is fresh air as well, so you can calculate for this. I will show you how to calculate for return and fresh air in other projects. So I hope you guys learned something from this video. If you learned something from this video, so please do subscribing and hit the bell icon as well once again, guys. So thank you for watching my video. Thank you. Bye bye.